In problem 1.1.21 or 21, it says from the graph of the function, state the domain, the range, and the intervals in which the function is increasing, decreasing, or constant, and complete for parts A and B. So we have two different graphs here. Let's start with A. So we want to find the domain first. So my domain, this is for A. And they're going to ask for interval notation. So I have a straight line here. There's a linear function. My graph is going to continue going up and left and down and right. So my domain would be all real numbers. Everything is allowed. So in interval notation, I would want to write that as negative infinity, positive infinity. Next, they want the range. Now, we already mentioned this. It's going to go up forever, and it's going to go down forever. So my y values, the same thing. It's all real numbers, right? Anything can be for y. So the same idea, negative infinity to positive infinity. We want our minimum and our maximum. Now, when is the function increasing? When is it decreasing? And when is it constant? All right, so increasing means when we're looking left to right, when is it going up? Well, if I'm reading left to right, my graph is not going up, right? It's decreasing. It has a negative slope. So when is it increasing? It's not, right? So it's never increasing. Now, when is it decreasing? Well, always. All right, it starts at infinity on the left, and then it's just going to keep going down for as long as this graph exists. It's just going to get smaller and smaller y value. So decreasing, always decreasing. And that would be from negative infinity to positive infinity if they're looking for interval notation. Now, when is it constant? That's when you're looking for like a horizontal line. It's not changing at all when you go left to right. So constant, it's never constant. All right, this linear function is always decreasing. So now let's look at part B. To close that out and that ledger. So we're doing the same thing here. We're looking for the domain, the range, and the increasing, decreasing, and constant. So my domain on this one goes left forever. All right, any x value is okay. It's going to keep going left, and it's going to keep going right. So my domain, again, is negative infinity to positive infinity. My range, on the other hand, I'm looking at minimum and maximums. So minimum comes first. What's the lowest number this graph is going to go to? Well, it's going to keep going down forever. So that would be negative infinity. And what is the largest number it can be in terms of the y values? Well, it goes up to 1. All right, and that's where it changes direction. Since it crosses at the 1, it does reach that. We want to make sure we put a bracket there. All right, so be careful to put a bracket with that 1. After that, increasing. Again, we're reading left to right. So it's increasing from our negative infinity. And it keeps going up until we get to that point where it's 0, 1. So my graph, this point right here, it's going to keep going. And right at this point here is where it starts to change. Okay, so it's increasing for this whole portion. Now, when we're talking about increasing and decreasing, we're talking in terms of x values. So my x value at that point is going to be 0. Now, what about decreasing? Well, when we get to that point of x being 0 and then y being 1, now my graph changes direction and it starts to decrease. Okay, so the graph is going to go down at this point. So that happens at 0. And then it goes forever. It's going to keep going down to the right. So 0 to infinity. And then finally, when is this graph constant? When is it ever horizontal? Well, it never is. it increases, and as soon as it stops increasing, it decreases right away. So constant, it's never constant. So remember, increasing is when it's going up from left to right. Decreasing is when it's going down from left to right. It can change directions, as we see in this parabola in part B. And constant would be something that looked like, if you had the graph here, your graph, maybe it goes up and then it's flat, it stays the same, and then maybe it goes back down. But this flat part here is when it would be constant, and that doesn't happen in either one of our examples.